All right, dear children, welcome back to the class. We're looking at the chapter called Alternating Current, right? So here we are at the second lecture of Alternating Current. See, whatever I have taught in the first class already, you must be well aware about all those things. Moving forward, now look at this. There are some components, okay, some electrical components which are very important in this chapter. Now look at this. If I draw like this, what do you understand by this? Don't you think it is a resistance? And I have some inductor, and this is some capacitor, no? This is L. L means inductance, and it is C. It is a resistor, no? Everybody knows about it, no? Resistor, inductor, and capacitor, right? Yes, you must have seen this already. Capacitor you have seen in second chapter. Electrostatic potential and capacitance. Inductor you have seen in electromagnetic induction. Resistance you have seen in current electricity. These are the three components. Now, it's very important to understand. For example, this resistance, whatever it is there, if it is connected to a battery, for example, this is a DC battery. Yeah? This is a DC source. We are not talking about AC source as of now. We'll discuss about AC source also. In this, because of this DC source, there is some current, okay, I current, which is flowing in it. Now this current, whatever current is there, no, this current into resistance is the voltage drop. Everybody knows about it, no? For example, if you are connecting any voltmeter here across this resistor, what is the reading of this voltmeter? Whatever this voltmeter is there, no? Reading of this voltmeter, reading of voltmeter. How much it will become? Reading of voltmeter is equal to I into R. Everybody knows it, and this is only known as Ohm's law. Okay, everybody knows it. Now, instead of this DC source, if you are connecting AC source, what will happen? AC source means how it will be? V is equal to V naught sine omega t. Something will be like that, no? So, due to that, some current I naught will be flowing, peak current, or you may take other current also. This is a resistance R. Now, if you connect any voltmeter here, so the reading of this voltmeter or voltage across this voltmeter is same, I naught into R, same, no change at all. This is the resistance circuit. What is this? Whenever AC is applied to, this is AC applied to AC source, alternating current applied to resistive circuit, resistive circuit. Okay, resistive circuit. All right. Now, similarly, if inductor is connected, what will happen? For example, this inductor is having inductance L, no? So now this is connected to AC source like this. Okay, V is equal to V naught sine omega t if it is connected like this. Now in this current I naught is flowing, no? Now you cannot say if for example if you are connecting any voltmeter here, now you cannot say the reading of this voltmeter is equal to I naught into L. If you say I naught into L, it becomes wrong. No. You cannot say like this. I naught into L. This is completely wrong. Now, before getting this, L means this is inductance, dear children. Whatever L is there, no, this is inductance. I cannot do like that. Now, we introduce one quantity here that is called as XL. XL is equal to, we have something called omega L. XL means, you understand what is the meaning of XL, dear children? The meaning of XL is inductive reactance. What is this? This is known as inductive reactance. And omega, angular frequency, already you know this. Okay, yesterday I have discussed about it, angular frequency. And what is L? L is like inductance. Okay, so first of all, you need to understand this. XL is equal to omega L. So whenever I have some inductor L, it will be having inductive reactance, that is XL. Now, this whatever this inductor is there, no, this inductor, and it is connected to AC source, and this AC source is like V is equal to V naught sine omega t, and this is inductor L, and it will be having some inductive reactance XL, which is equal to omega L. Already I have told you this. Now, whenever you are connecting the voltmeter, no, what will be the reading of this voltmeter? The reading of this voltmeter is equal to I into XL. Very, very important. What is that? I into XL. Please remember this. And what is the value of XL? XL is equal to omega L. And omega we have here, and L is already given. So that's why voltage drop becomes I into XL. Now, whatever this XL is there, no, that name I already have told you. What is the name of this? Inductive reactance. Inductive reactance name is there, but it is just like resistance only. Inductive reactance is there, and it is just like resistance only, just like resistance. Inductive reactance means you can say it is the resistance of inductor. What is this? It is the resistance of inductor. Now it has to follow Ohm's law. In Ohm's law, I cannot use I into L. I into L becomes wrong. I have to use I into XL. Is it clear to everyone? Is it clear or not? Yes, whatever I have explained, is it clear? Okay, so I have this capacitor also. Now this capacitor is connected to AC source. Now this AC source is equal to V is equal to V naught sine omega t. Now I have some capacitance here. Now if I connect a voltmeter here, now definitely now also you cannot say the voltage across this voltmeter. I mean here the current will be I naught. You cannot say I naught into C. No, it also becomes wrong. Okay. So before that we introduce one quantity that is called as omega C. What is this? Omega C. Omega C is equal to, no, I mean not omega C, XC. XC. XC is equal to the formula for this is 1 by omega C. And the meaning of this, whatever XC is there, no? This is called as a capacitive reactance. What is this? Capacitive reactance. Okay, reactance means resistance only. Capacitive reactance it is. Okay, that XL, whatever it is there, that XL is inductive reactance, and this XC is a capacitive reactance, and formula is 1 by omega C. 1 by omega C. Now you can say voltage drop in the capacitor is equal to I into XC. Okay, I into X, or you can say I naught, whatever current is there, no, that current you have to consider and you have to write that. I hope everybody is understanding. And here current is I means you have to take I into XL, I naught means I naught into XL you have to take. So basically what I'm trying to tell is that this is the resistor, this is the inductor, this is the capacitor. Okay, now this is connected to AC source. What will be the AC source? V is equal to V naught sine omega t. Now this is resistance R, this is inductor L, and this is capacitance C. Here voltage drop will be VR. VR means voltage drop in resistor. Here the voltage drop is VL. VL means voltage drop in inductor, and this is a VC. VC means voltage drop in capacitor. Now what is the formula? For example, I have got current I naught here. What is the voltage drop in resistor? Voltage drop in resistor is equal to I naught into R. Voltage drop in inductor is equal to I naught into XL. Very, very important. You cannot write I naught into L directly. You have to write I naught into XL. Voltage drop in capacitor is equal to I naught into XC. Okay, this is XL. Okay, so XL, and you know the formula for XL and XC. XL is equal to omega L. XC is equal to 1 by omega C. Okay, XL means inductive reactance. XC means capacitive reactance. Are these things very, very clear, dear children? If they are clear to you, please say yes. Yes.
So,
Confirm. Okay, fine. So these are the things which you should be knowing. And one more thing I want to put forward here is XL is equal to, I told you, omega L. No, omega means what? 2 pi f. Yesterday we have seen this 2 pi fl. Omega is equal to 2 pi by t was there, no? 2 pi by t was written as 2 pi into 1 by t. So that's why it can be written as 2 pi f. So instead of omega, you can write 2 pi f also. Okay. So similarly, you can write for xc also. Xc is equal to 1 by omega c, right? 1 by omega c means it becomes 1 by 2 pi fc. Okay. According to the given situation, you should be able to find out xc and xl. All right. Okay, fine. So now I have drawn this diagram also. Now look at this. Is this a series circuit? All the components are connected in series, no? This is resistor, this inductor, this is L, and this is V is equal to V naught sine omega t is there. Now, whatever circuit I have drawn above there, that is called as series RLC circuit. What is that? Series RLC circuit, and this is very important for us because this is there in our syllabus. This is resistor, inductor, and capacitor, and they're connected in a series. That's why it is known as series RLC circuit. Okay, fine. Shall we do some problems on this? Simple problems? Yes, dear children.
Yes, sir.
Shall we do some? Okay. Now let me do this. Very simple it is. Okay. Resistance of resistor of resistance 10 ohm, inductor of inductance 10 millihenry, and capacitance of capacitor, no, it is capacitor of capacitance 2 microfarad are connected in series. If this combination is connected to AC source of V is equal to 100 sine 100t, find a peak voltage drop. Okay, peak voltage drop we cannot find it out now, and current also we cannot find it out now. Okay, because we need to understand few more things. Okay, because how to find out the current we did not get to know about that. Okay, only please write this question and leave it as of now. I want to give you some more input. Okay, without understanding those inputs you cannot get it. Otherwise you can just do that. Find inductive reactance. Okay, you do this. Find inductive reactance, and B, capacitive reactance. Okay, find out these things, inductive reactance and capacitive reactance. You'll get to know about these things. Resistor of resistance 10 ohm. Okay, there is a resistor of 10 ohm. Next, this is a resistance 10 ohm. Then I have inductance of 10 millihenry. Here is a L is equal to 10 millihenry, and then I have capacitor. So this is the capacitance of 2 microfarad. Now this is connected. Where it is connected? It is connected to AC source. What is this AC source? This is 100 sine 100t. Okay. Now what they're asking? They're asking inductive reactance. Okay. Inductive reactance means XL, no? XL is equal to, what is the formula? Omega L. And what is the value of omega? Look at this. Omega is 100, no, dear children? From this formula, you can see, right? V is equal to V naught sine omega t. You can always rely on that. Okay. So omega is 100 into L. What is the value of L? L is 10 millihenry. 10 millihenry means 10 into 10 to the power minus 3. Very, very important. Okay. You cannot take directly 10. You have to take it as 10 into 10 to the power minus 3. So how much it becomes? It becomes 100 I mean, this can be written as 100 can be written as 10 to the power 2, and this is again so 10 to the power 3 into 10 to the power minus 3. That is like 10 to the power 0. 10 to the power 0 means 1. And what is the unit of inductive reactance? It is like resistance only, no? So that's why ohm. XL is equal to 1 ohm. So whatever this inductor is there, no, dear children, this inductor, it is going to offer a resistance of how much resistance it will offer? It will offer a resistance of inductive reactance of 1 ohm. That's it. As it is 10 ohm, no? So it is having capacity of 1 ohm. So that's it. That is the meaning of it. Okay. Similarly, you can go for, see, these have to be kept in SI units only. You cannot take in millihenry and all. You have to take them in Henry only. Okay. XC is equal to 1 by omega C. 1 divided by omega means how much it is there again? 100 into C means what is C? 2 microfarad. 2 microfarad means you have to make it as 2 into 10 to the power minus 6. All right. Then afterwards, 1 divided by here 10 to the power 2 it is, and into 2 into 10 to the power minus 6. You can do these calculations. It becomes 10 to the power 2 and 10 to the power minus 6 means it becomes 10 to the power minus 4 into 2. 10 to the power minus 4 goes above and become 10 to the power 4 divided by 2. So it becomes 1, 0, 0, 0, 0 divided by 2. 2 ones are 2 fives are and 0, 0, 0. So that is like 5,000 now. So in this is XC, right? So XC is going to be 5,000 ohm. Is it clear whatever I have told till now, dear children? Is it clear? So this XC, whatever XC I'm going to get, that is going to be 5,000 ohm. So everybody must have understood about inductive reactance and capacitive reactance, right? Okay. Now one more thing I want to emphasize here is now R, like that three resistors are there. One, for example, this is A and this is B. Now this is 2 ohm, 3 ohm and 4 ohm. Okay, I have resistors like this. Now instead of this all resistors between A and B, I want to write only one resistor. What will be the value of this resistance? Please tell me someone. Please someone tell me.
9
Can
from
someone? Yes, 9 ohm, no? So I can, I mean, I have to place it like this, no? I mean, and parallel also we know how to do. Okay. Now, how about this? This is R, this is L, and this is C. Okay. Now, this is between point A and point B. Now, instead of this, this is like one module. This is a different module. Now, instead of this, I want to place only one thing. Okay, between this point A and point B, I want to place only one thing. So whatever I place here, no, so this is called as impedance. What is this, dear children? This is called as impedance. I cannot call it as resistor. Oh, no, I cannot call it as resistor. No, why? Because resistor is also there, inductor is also there, capacitor is also there, correct? So I cannot call it as a resistor or inductor or a capacitor. I have to call it as impedance. So this is the impedance, what we are going to call. So instead of all these components, now I'm going to have impedance. The symbol for impedance is this is A. Symbol for impedance is Z. Okay, symbol. Okay, we use the symbol Z for impedance. So what is the meaning of Z? Z means it is impedance. Is it clear? Is it clear whatever I have told? Yes. So and the formula for impedance Z is, please write down, I will derive and I will show you. Z is equal to under root R square plus XL minus XC whole square. Under root R square plus XL minus XC whole square. So this is the formula of impedance. Is it okay? How it came, we'll see the derivation. How? Why, sir? You may be asking why. Then we'll look into the derivation. No need to worry about that. Right now, you have to understand this is the formula for impedance. Okay. So what I'm trying to tell here is that whenever I have one resistor, I have inductor, I have capacitor here. Now this is connected to some source here. Okay. Some source V is equal to V naught sine omega t. Now, if I want to find out the current I naught, how will I find the current I naught? Because I have R also, I have L also, I have C also. Okay. So right now I'm not able to find out current I naught directly. If only resistor was there, I would have directly calculated. Only resistor means, I mean, what I would have done. So here is a V is equal to V naught sine omega t is there. And if I wanted to find out I naught means, easily I would have said I naught is equal to V naught divided by R. Directly I would have said, correct? Now inductor, only inductor is there. Again, I would have said inductor is there, and here is the I mean AC source V is equal to V naught sine omega t. Okay, and here current I naught is flowing, and this is inductor L. Inductive reactance is omega L. Then directly I would have said I naught is equal to, tell me, V naught divided by XL. Correct? V naught divided by XL. Similarly with the capacitor. Okay, only one capacitor is there, and I have AC source here. This is V is equal to V naught sine omega t. correct? V naught sin omega t, and then in this current I naught is passing, this is capacitance, then I get I naught is equal to V naught divided by xc. I cannot write c, no, xc. So these things were I mean individually when we use, we can use them, but together when we are using them, which one to use? I have to use all of them, no? So that's why instead of all these things, okay, instead of all that R, L and C, I'm going to use something called impedance, or just I write it as Z, impedance, and this will be connected to AC source. Okay, this is the AC source what I'm connecting here. So this is the AC source. So this is like a V is equal to V naught sin omega t. Now if I want to find out the current, means this current is equal to, tell me, V naught divided by Z. Is it clear whatever I have told right now? Clear or not? Please confirm, dear children. Is it clear or not? Yes.
Sir, ಇನ್ನೊಮ್ಮೆ ಹೇಳ್ರಿ.
Okay. Innum ಹೇಳ್ರಿ sir. All right. See, this resistor I have to. So this resistor I am having means it's quite simple. So here I have connected it with some voltage V equal to V naught sin omega t. ಇದ್ರೊಳಗಡೆ ಕರೆಂಟ್ ಐ ನಾಟ್ ಫ್ಲೋ ಆಕೈತೆ ಅಂದ್ರೆ ಬಾರಿ ಸಿಂಪಲ್ ರೀ. ಇದೇನಿದು ಐ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಿ ನಾಟ್ ಬೈ ಆರ್ ಅಂತ ಮಾಡಿಬಿಡ್ತೇವೆ. ಆಮೇಲೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇದ್ರೊಳಗಡೆ ಏನಾದ್ರು ನಾವು ಇಂಡಕ್ಟರ್ ಅಷ್ಟೇ ಐತಂದ್ರೆ ಇದಕ್ಕೆ ಒಮೆಗಾ ಎಲ್ ಅಂತ ಹಿಡಿತೇವೆ, ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟನ್ಸ್ ಅಂತ ಹೇಳಿ ನಿಮಗೆ. ಒಮೆಗಾ ಎಲ್ ಅಂದ್ರೆ ಫಾರ್ಮುಲಾ ಏನು? ಒಮೆಗಾ ಎಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಸಾರಿ ಒಮೆಗಾ ಎಲ್ ಅಲ್ಲ, ಏನಿದು ಎಕ್ಸೆಲ್ ಅಲ್ಲ, ಐ ಆಮ್ ರಿಯಲಿ ಸಾರಿ. ಎಕ್ಸೆಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಂತ ಬರೀತೀನಿ ನಾನು? ಒಮೆಗಾ ಇಂಟು ಎಲ್. ಎಕ್ಸೆಲ್ ಅಂದ್ರೆ ಎಕ್ಸ್, ಕೆಳಗಡೆ ಸಫಿಕ್ಸ್ ಎಲ್ ಇದು. ಸೊ ಎಕ್ಸೆಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಒಮೆಗಾ ಎಲ್ ಅಂತ ಬರೀತೀನ. ಎಕ್ಸೆಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಒಮೆಗಾ ಇಂಟು ಎಲ್ ಅಂತ ಬರೀತೀನಿ. ಸೊ ಅವಾಗ ಕರೆಂಟ್ ಏನಾದ್ರು ನಾ ಐ ನಾಟ್ ಕಂಡು ಹಿಡಿಬೇಕಂದ್ರೆ ಐ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗ್ತದೆ? ವಿ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಎಕ್ಸೆಲ್ ಅಂತ ಹೇಳಿ ಆಗಿಬಿಡ್ತದೆ ಇದು. ಹೌದಾ? ಅದು ಕೂಡ ಗೊತ್ತದ. ಆಮೇಲೆ ಕೆಪಾಸಿಟನ್ಸ್ ಇತ್ತು, ಅದನ್ನೇನಾದ್ರು ಎ ಸಿ ಸೋರ್ಸ್ ಹಿಂಗ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಐ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಿ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಎಕ್ಸ್ ಅಂತ ಆಗಿಬಿಡ್ತದ. ಅದ ಏನಾದ್ರು ಈ ಮೂರು ಕೂಡಿದ್ದು ತಿಳ್ಕೊರಿ, ಆರ್, ಎಲ್ ಮತ್ತ ಸಿ ಮೂರು ಇದ್ರೆ ಏನ್ ಮಾಡೋದು? ಈಗ ಎ ಸಿ ಸೋರ್ಸ್ ಹಿಂಗ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಇದ್ರೊಳಗಡೆ ವಿ ನಾಟ್ ಸೈನ್ ಒಮೆಗಾ ಟಿ ಅಂತ ಹೇಳಿದ್ರೆ ಐತೆ. ಸೊ ಇದ್ರ ಒಳಗಡೆ ನಾ ಎಷ್ಟ್ ಕರೆಂಟ್ ಆಕೈತಿ? ಐ ನಾಟ್ ಕರೆಂಟ್ ಆಕೈತಿ. ಬಟ್ ಹೆಂಗ್ ಕಂಡು ಹಿಡಿಬೇಕು ಅಂತಂದಾಗ ಇದು ಆರ್ ಎಲ್ ಸಿ ಐತೆ ಅಂದಾಗ ಅವಾಗ ಐ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಫಾರ್ಮುಲಾ ಏನಕ್ಕೆ ಹೇಳಿ ನೋಡೋಣ? ವಿ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಝೆಡ್ ಆಕೈತಿ. ಓಕೆ, ಪೀಕ್ ಕರೆಂಟ್ ಇದ್ರೆ ಪೀಕ್ ವೋಲ್ಟೇಜ್ ತಗೋಬೇಕ. ಸೊ ಐ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಿ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಝೆಡ್ ಆಕೈತ್ರಿ. ಈ ಝೆಡ್ ಅದ ನೋಡ್ರಿ, ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೆ? ಇಂಪಿಡೆನ್ಸ್ ರೀ. ಇಂಪಿಡೆನ್ಸ್ ಅಂದ್ರೆ ಏನ್ ಗೊತ್ತೇನ್ರಿ? ಇಂಪಿಡೆನ್ಸ್ ಅಂದ್ರೆ ಮೀನಿಂಗ್ ಏನಂದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಸೀರೀಸ್ ಆರ್ ಎಲ್ ಸಿ ಸರ್ಕ್ಯೂಟ್ ರೀ. ಏನ್ ಹೇಳ್ರಿ? ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಸೀರೀಸ್ ಆರ್ ಎಲ್ ಸಿ ಸರ್ಕ್ಯೂಟ್. ಸೀರೀಸ್ ಆರ್ ಎಲ್ ಸಿ ಸರ್ಕ್ಯೂಟ್ ಏನೈತಿ ನೋಡ್ರಿ, ಅದರ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇದ್ದಂಗ್ರಿ ಇದು ಝೆಡ್ ಅಂದ್ರ. ಓಕೆ, ಸೊ ಝೆಡ್ ದ ಫಾರ್ಮುಲಾ ಹೇಳಿಲ್ಲ ನಾವ್ ಇದೀಗ ನಿಮಗ. ಝೆಡ್ ದ ಫಾರ್ಮುಲಾ ಏನು? ಅಂಡರ್ ರೂಟ್ ಆರ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎಕ್ಸ್ ಎಲ್ ಮೈನಸ್ ಎಕ್ಸ್ ಸಿ ಹೋಲ್ ಸ್ಕ್ವೇರ್. ತಿಳಿತ್ರಿ? ಈಗ ಒಂದಿಟ ಕನ್ಫರ್ಮ್ ಮಾಡ್ಬೇಕು ಜಲ್ದಿ, ಅಂದ್ರೆ ಮುಂದೆ ಹೋಗಕ. ಓಕೆ, ಸೊ ಇದನ್ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದಂಗ ನೆನಪು ಇಟ್ಕೊಂಡ ನೀವು ಹೆಂಗ ಮುಂದೆ ಹೋಗ್ತೀರಿ ಹಂಗ ನೆನಪು ಉಳಿತದೆ ಇದು. ಓಕೆ, ಏನ್ ವರಿ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಒಂದ್ ಕ್ವಶನ್ ಮಾಡ್ರಿ ತಾನ ಗೊತ್ತಾಗೈತಿ. ಓಕೆ, ಇನ್ ಎ ಸೀರೀಸ್ ಆರ್ ಎಲ್ ಸಿ ಸರ್ಕ್ಯೂಟ್, ಇನ್ ಎ ಸೀರೀಸ್ ಆರ್ ಎಲ್ ಸಿ ಸರ್ಕ್ಯೂಟ್, ಸ್ವಲ್ಪ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಮುಂದೆ ಇಟ್ಕೊಂಡ್ ಕೊಡ್ರೆ. ಇನ್ ಎ ಸೀರೀಸ್ ಆರ್ ಎಲ್ ಸಿ ಸರ್ಕ್ಯೂಟ್, ಆರ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 10 ohm, ಎಲ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 10 millihenry, and capacitance is equal to 5 microfarad. It is connected to AC source of V is equal to 10 sin 10t. Find impedance of the circuit. Okay, impedance ಕಂಡುಹಿಡಿಬೇಕ್ರಿ. ಹೆಂಗ್ರಿ ಇದು? ಇನ್ ಎ ಸೀರೀಸ್ ಆರ್ ಎಲ್ ಸಿ ಸರ್ಕ್ಯೂಟ್ ಅಂದ್ರೆ ಆರ್ ಎಲ್ ಸಿ ಈ ರೀತಿಯ ಮೂರು ಅದಾವು. ಇದನ್ನ ತಗೊಂಬಂದ್ ಎ ಸಿ ಸೋರ್ಸ್ ಹಿಂಗ್ ಜೋಡ್ಸ್ಯಾರ. ಇಲ್ಲಿ ಎ ಸಿ ಸೋರ್ಸ್ ಏನದ? ಇದು ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು 10 sin 10t ಐತಿ. ಆಮೇಲೆ ಇದು ಆರ್ ಅಂದ್ರೆ ಎಷ್ಟೈತ್ರಿ? ಇಲ್ಲಿ 10 ohm, ಇದು 10 millihenry, ಇದು 5 microfarad ಐತ್ರಿ. ಹೌದಾ? ಬೇಕಾದ್ರೆ ಬರ್ಕೋರೆಲ್ಲ. ಹೌದಾ? ಏನೇನ್ ಬೇಕಾಗ್ಯದ? ಆರ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 10 ohm, ಎಲ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 10 millihenry ಅಂದ್ರೆ 10 into 10 to the power minus 3 ಅಂದ್ರೆ 10 to the power minus 2 ಹೆನ್ರಿ ಆಗೈತಿ. C is equal to 5 microfarad, 5 into 10 to the power minus 6 farad. ಇಷ್ಟು ಅದಾವ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲೇ ವಿ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನದ ರೀ 10 ವೋಲ್ಟ್ ಅದ. ಒಮೆಗಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನದ 10 ರೇಡಿಯನ್ ಪರ್ ಸೆಕೆಂಡ್ ಅದ. ಇಷ್ಟೆಲ್ಲ ಡೀಟೇಲ್ ಗೊತ್ತಾಕೈತ್ಲ ಅದು ಬರ್ಕೊಂಡಿದ್ದು. ನೀವು ನಿನ್ನೆ ಕ್ಲಾಸ್ ನೋಡಿದ್ರೆ ಇಷ್ಟೆಲ್ಲ ಹೆಂಗ್ ಬರ್ಕೋಬೇಕು ಅನ್ನೋದು ನಿಮ್ಗೆ ಗೊತ್ತಾಗಿರ್ತದೆ. ಇವತ್ತಿನ ಕ್ಲಾಸ್ ನಿನ್ನಿದು ಎಲ್ಲ ಮಾಡಿ. ಈಗ ನಮಗೇನ್ ಬೇಕು, ಇಂಪಿಡೆನ್ಸ್ ಕಂಡಿಡಿ ಅಂದಾರ ಅವ್ರು. ಇಂಪಿಡೆನ್ಸ್ ಅಂದ್ರೆ ಏನ್ ಫಾರ್ಮುಲಾ, Z ಇಸ್ ಈಕ್ವಲ್ ಟು ಅಂಡರ್ ರೂಟ್ ಆರ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ XL ಮೈನಸ್ XC ಹೋಲ್ ಸ್ಕ್ವೇರ್. ಹೌದಾ? ಸೊ ಆರ್ ಗೊತ್ತೈತೆ, XL ಬೇಕೀಗ. XL ಇಸ್ ಈಕ್ವಲ್ ಟು ಫಾರ್ಮುಲಾ ಏನು, ಒಮೆಗಾ ಎಲ್, ಹೌದಿಲ್ಲ? ಸೊ ಒಮೆಗಾ ಅಂದ್ರೆ ಎಷ್ಟು ಅದ ರೀ 10 ಇಂಟು ಎಲ್ ಅಂದ್ರೆ ಎಷ್ಟು ಅದ 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 2. ಅದಕ್ಕೆ 10 ಇಂಟು 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 2 ಅಂದ್ರೆ 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 1. 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 1 ಅಂದ್ರೆ 1/10. 1/10 ಅಂದ್ರೆ 0.1 ಓಮ್ ಇದ್ದಂಗ್ರಿ ಇದು. ಎಕ್ಸೆಲ್ ಅಂದ್ರೆ ಓಮ್ ಇದ್ದಂಗೆ ಇದು 0.1 ಓಮ್. ಹೌದಾ? ನೆಕ್ಸ್ಟ್ ಅದೇ ರೀತಿಯಾಗಿ ಏನ್ ಕಂಡುಹಿಡಿಬೇಕು ಈಗ, ಎಕ್ಸಿ. ಎಕ್ಸಿ ಅಂದ್ರೆ ಏನಾಗ್ತದ ರೀ 1/ωc. 1/ωc ಅಂದ್ರೆ 1/ω ಎಷ್ಟದ 10 ಇಂಟು ಸಿ ಅಂದ್ರೆ ಎಷ್ಟದ ರೀ ಇಲ್ಲಿ, ಸಿ ಇಲ್ಲಿ ಕಂಡುಹಿಡಿದ್ವಿ ನೋಡ್ರಿ 5 ಇಂಟು 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 6. 5 ಇಂಟು 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 6. ಹೌದಾ? ಸೊ 1 ಡಿವೈಡೆಡ್ ಬೈ 10 ಇಂಟು 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 6 ಅಂದ್ರೆ ಏನಾಗ್ತದೆ ಇದು 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 5 ಇಂಟು 5. ಸೊ 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 5 ಮ್ಯಾಲ್ ಹೋಗ್ತೈತ್ರಿ, 10 ಟು ದ ಪವರ್ ಪ್ಲಸ್ 5 ಆಗ್ತೈತಿ, ಡಿವೈಡೆಡ್ ಬೈ 5 ಆಗ್ತದೆ. ಬೇಸಿಕ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ 1 0 0 0 0 0 ಡಿವೈಡೆಡ್ ಬೈ 5 ಅಂದ್ರೆ 5 1 ಜ 5 2 ಜ then 0 0 0 0 4 zeros. So that is equal to 20,000 ಓಮ್ ಆಗ್ತದೆ ರೀ. ಕರೆಕ್ಟ್ ರೀ? ನೋಡ್ರಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಎಲ್ಲ ಕರೆಕ್ಟ್ ಐತಿಲ್ಲ ನೋಡ್ಬೇಕೆಲ್ಲ. ಸೊ ಎಕ್ಸ್ ಸಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಷ್ಟು ಆಗ್ತದೆ ಇದು 20,000 ಓಮ್ ಆಗ್ತದೆ ಇಲ್ಲ. ಎಕ್ಸ್ ಸಿ ಇರ್ಲಿ, ಏನದ ಇರ್ವಲ್ದಕ್ಕ ಅದು. ನಮ್ಗೆ ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಅದನ್ನಂತರೂ ಮಾಡೋದು ನಾವು. ಕರೆಕ್ಟ್? Now I want
Yes.
impedance. Impedance is equal to what? Under root R square. R square ಅಂದ್ರೆ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಅದ ರೀ, R ಅಂದ್ರೆ 10 ಅದ, ಅದಕ್ಕೆ R square ಅಂದ್ರೆ 10 ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ XL ಮೈನಸ್ XC ಅಂತಾರೆ. XL ಅಂದ್ರೆ ಏನೈತ್ರಿ 0.1 ಮೈನಸ್ XC ಅಂದ್ರೆ 20,000 ಆದ್ರೆ 20,000. ಆಮೇಲೆ ಅದಕ್ಕೆ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಮಾಡ್ಬೇಕು. ಕರೆಕ್ಟಾ? ಸೊ Z ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗ್ತದೆ ಇದು ಅಂಡರ್ ರೂಟ್ 10 ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ 100 ಪ್ಲಸ್ 0.1 ಮೈನಸ್ 20,000 ಅಂದ್ರೆ ಇದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಒಳಗೆ ಹಾಕಿ ಮಾಡಿರ್ತೀರಿ ನೀವು. ಮಾಡಕ್ ಬರ್ತೈತಿಲ್ಲ ನಿಮಗೆ, ಎಷ್ಟಾಗ್ತದೆ ಇದು ಮೈನಸ್ 19,999.9 ಆಗ್ತದ. ಹೌದಾ? ಸೊ ಇದಕ್ಕೆ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಮಾಡ್ಬೇಕು. ಕರೆಕ್ಟಾ? ನೋಡ್ಬೇಕಾರ ಮಾಡಿ. ಓಕೆ, Z ಈಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗ್ತದೆ ಅಂಡರ್ ರೂಟ್ 100 ಪ್ಲಸ್ ಇದ್ರದ್ದು ಸ್ಕ್ವೇರ್ ಕಂಡುಹಿಡಿಯಕ್ ಬರ್ತೈತಿಲ್ಲ ನಿಮಗೆ, ಮೈನಸ್ 19,999.9 ಇಂಟು ಮೈನಸ್ 19,999 ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಏನೋ ಒಂದು ಆನ್ಸರ್ ಬರ್ತೈತಿ. ಅದನ್ನ ಹೇಳ್ತೀರಿ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಹಾಕಿ ಪಟ್ನ. ಈಗ ಅದನ್ನ ಹೇಳಿದ್ರೆ ಅಂದ್ರೆ ನಾ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಕ್ಯಾರಿ ಫಾರ್ವರ್ಡ್ ಮಾಡಕ್ ಬರ್ತೈತಿ. ಓಕೆ, ಬೇಕಾದ್ರೆ ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಓಪನ್ ಮಾಡಿ ತೋರಿಸಂದ್ರೆ ತೋರಿಸ್ತೀನಿ ಇಲ್ಲೇ. ಬಟ್ ನಾ ಇವತ್ತು ಇದ್ರೊಳಗೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಓಪನ್ ಮಾಡಿಲ್ಲ ಒಮ್ಮೆ. ಓಕೆ, ಲೆಟ್ಸ್ ಸಿ. ಎಲ್ಲದ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಎಲ್ಲದ. ಸೊ ಏನದ ಅದು 19,999.9. ಹೌದಾ? ಇದಕ್ಕೆ ಏನ್ ಮಾಡಬೇಕು, ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕು. ಇದ್ರ ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ರೆ ಇಷ್ಟ ಆನ್ಸರ್ ಬರ್ತದೆ ನೋಡ್ರಿ, ಇಲ್ಲದ ನೋಡ್ರಿ. ಓಕೆ, ಬರ್ಕೋರಿ ಎಲ್ಲಾರು ಇದನ್ನ, ನನಗೆ ರಿಪೀಟ್ ಮಾಡಕ್ ಆಗ್ತದ ನೀವು. 39999. ಓಕೆ, ಹೇಳ್ರಿ ಏನ್ ಬರೀಬೇಕಿಲ್ಲ. 39999 4 ಸರಿ ಬರ್ತೇನ್ರಿ. ಮತ್ ಮುಂದ್ರಿ ಮುಂದೇನ
6.
6,000. 6,000.01 ಕರೆಕ್ಟಾ? ಹೌದಲ್ರಿ? ಆಮೇಲೆ ಇವನ್ ಆಡ್ ಮಾಡ್ರಿ. ಇವನ್ ಆಡ್ ಮಾಡೋಣ ಏನಾಕೈತಿ ನೋಡ್ರಿ ಇಲ್ಲೇ 39999 600. 6 ಮುಂದೆ ಇಲ್ಲಿ 00 ಇದಲ್ಲಿ 100.01. ಇದ್ರ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಮಾಡ್ರಿ. ಇದ್ರ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಮಾಡಿ ಏನ್ ಬರ್ತೈತೆ ನಾನು ಆನ್ಸರ್ ಬರದ್ ಬಿಡ್ರಿ. ದೀಸ್ ಮೆನಿ ಓಮ್ಸ್ ಅಂತ ಹೇಳಿ. ಇಂಪಿಡೆನ್ಸ್ ಅದು ಯೂನಿಟ್ ಓಮ್ ರೀ. ಓಕೆ, ಯೂನಿಟ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅದಂತರೂ ಓಮ್ ಐತಿ. ಯೂನಿಟ್ ಆಫ್ ಎಕ್ಸೆಲ್ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟನ್ಸ್ ಓಮ್ ರೀ, 1 ಮಾರ್ಕಿಗೆ ಕೇಳ್ತಾರೆ. ಯೂನಿಟ್ ಆಫ್ ಎಕ್ಸ್ ಈಸ್ ಆಲ್ಸೋ ಓಮ್. ಯೂನಿಟ್ ಆಫ್ ಝಡ್ ಆಲ್ಸೋ ಓಮ್. ಇವೆಲ್ಲ ಯೂನಿಟ್ಗಳು ಏನಾಗ್ತಾವ್ರಿ ಓಮ್ನ ಆಗ್ತಾವ. ತಿಳಿತಿ? ಕ್ಲಿಯರ್ನೋ? ಮಾಡ್ತಿರ್ಲೇ? Yes. Square root of ಎಂಟದು 39999 ಮುಂದೇನೈತ್ರಿ 39999 6100 6100 6100 ಕರೆಕ್ಟ್ ಐತಿಲ್ರಿ? ಸರಿ 96100.01 ಕ್ಯಾಲ್ಕುಲೇಷನ್ ರೀ. ಇದನ್ನಾರ ಮಾಡಬೇಕಾಗ್ತದೆ, ನೀವು ಏನು ಮಾಡಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಸೊ ಎಷ್ಟಾಗ್ತದೆ ನೋಡ್ರಿ, ಹೊಳ್ಳಿ ಇಷ್ಟು ಬರ್ತದೆ 19,999.9 ಬರ್ತದೆ ರೀ. ಓಕೆ, ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ. ಸೊ 19,999.9. ಓಕೆ, ಇಲ್ಲಿ ಬಂದೈತಿ ನೋಡ್ರಿ ಆನ್ಸರ್. ಬೇಕಾದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಏನ ಮಾಡಿ ಹೇಳಿನಿ, ನೀವು ಕ್ವಿಕ್ ಇರಬೇಕು ಈ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ಸೊ ದೋಸ್ ಮೆನಿ ಓಮ್ ಇಟ್ ಇಸ್ ಕ್ಲಿಯರ್. ಕ್ಲಿಯರ್ ಆದಿಲ್ರಿಪ್ಪ ಬಟ್ ಓಕೆ. ಸೊ ದೀಸ್ ಮೆನಿ ಓಮ್ ಇಸ್ ದ ಇಂಪಿಡೆನ್ಸ್. ಇಂಥವು ಇನ್ನೊಂದ್ ಸ್ವಲ್ಪ ನಾನು ಕ್ವಶನ್ಸ್ ಕೊಡ್ತೀನಿ, ಇಂಪಿಡೆನ್ಸ್ ಕಂಡು ಹಿಡಿತೀರಿ ಎಲ್ಲಾರು. ವಿಲ್ ಯು ಫೈಂಡ್ ಔಟ್ ದ ಇಂಪಿಡೆನ್ಸ್? ಇದನ್ನ ಮಾಡಕ್ ಕಲ್ಕೋರಿ, ಆಮೇಲೆ ಮುಂದಿನ ನೋಡೋಣ ಏನಾಗ್ತದ ಅಂತ ಹೇಳಿ. ಇಂಪಿಡೆನ್ಸ್ ಏನಂತ ಹೇಳಿ ಕಂಡು ಹಿಡಿಯಕ್ ಕಲ್ಕೋತೀರಿ? ಒಂದೇ ಕ್ವಶನ್ ತಗೋರಿ, ಒಂದೇ ತಗೋರಿ. ಇಲ್ಲೊಂದು ರೆಸಿಸ್ಟರ್ ಐತ್ರಿ, ಇಲ್ಲೊಂದು ಇಂಡಕ್ಟರ್ ಐತ್ರಿ, ಇಲ್ಲೊಂದು ಕೆಪಾಸಿಟರ್ ಐತ್ರಿ. ಹೌದ್ರಿ? ಇದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟೈತಿ ಅಂದ್ರೆ 100 ಓಮ್ ಐತಿ. ಇದು 2 ಹೆನ್ರಿ ಐತಿ. ಇದು 2 ಫ್ಯಾರಡ್ ಐತಿ. ಮೈಕ್ರೋ ಫ್ಯಾರಡ್ ಅಂತ ಏನೂ ಇಲ್ಲ. ಇದನ್ನ ತಗೊಂಬಂದೆ ಹಿಂಗ್ ಜೋಡ್ಸ್ಯಾರ. ಇಲ್ಲಿ ಇದನ್ನ ಜೋಡ್ಸ್ಯಾರ. ಎಟ್ಟಕ್ ಜೋಡ್ಸ್ಯಾರಿ? V is equal to 100 sin 50 pi t ಅಂತ ಜೋಡ್ಸ್ಯಾರ್ರಿ. ಇದ್ರೊಳಗಡೆ ಕರೆಂಟ್ I0 ಹೋಗೈತಿ. ಈ ಸರ್ಕ್ಯೂಟ್ ನಾಗ ಏನ್ ಕೇಳ್ತಾರ? Z is equal to ಕ್ವಶನ್ ಮಾರ್ಕ್, I0 is equal to ಕ್ವಶನ್ ಮಾರ್ಕ್. ಓಕೆ, Z ಮತ್ತು I0 ಕೇಳಾಕತ್ತಾರ್ರಿ. ಹೌದ್ರಿ? ನೆಕ್ಸ್ಟ್ ಎರಡನೇ ಕ್ವಶನ್ ತಗೋರಿ. ಇಲ್ಲೇ ಒಂದು ಇಂಡಕ್ಟರ್ ಐತ್ರಿ. ಹೌದ್ರಿ? ಇದೊಂದು ಕೆಪಾಸಿಟರ್ ಐತ್ರಿ. ಇದನ್ನ ತಗೊಂಬಂದ್ ಒಂದು ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಕೊಟ್ಟಾರಿ. V is equal to ಇದು 220 sin 50 t ಐತ್ರಿ. ಇದು ಇಲ್ಲೇ 2 ಹೆನ್ರಿ ಐತ್ರಿ. ಇದು 6 ಫ್ಯಾರಡ್ ಐತ್ರಿ. ಈಗೇನ್ ಕೇಳತ್ತಾರ್ರಿ? ಈ I0 ರೀ. I0 is equal to ಕ್ವಶನ್ ಮಾರ್ಕ್ ಅಂತ ಕೇಳತ್ತಾರ್ರಿ. ಹೌದ್ರಿ? I0 ಎಷ್ಟದ ಕೇಳತ್ತಾರ. ಮತ್ತೆ ಇಂಪಿಡೆನ್ಸ್ is equal to ಕ್ವಶನ್ ಮಾರ್ಕ್. ಆರ್ ಇರ್ಲಿಕ್ಕನ ಬಿಟ್ಟು ಬಿಡುದ್ರಿ. ಅದನ್ನ ಬಿಟ್ಟು ಉಳಿದ ಫಾರ್ಮುಲಾ ಐತಿ, ಅದನ್ನ ಮಾಡೋದು. ಮಾಡ್ತೀರಿ ನೀವು ಎರಡು ಪ್ರಾಬ್ಲಮ್? ಮಾಡ್ತಿರಿಲ್ಲ? ಇವೆರಡು ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ರಿ. ಮಾಡಿ ಆದ್ಮೇಲೆ ನನಗ ಆನ್ಸರ್ ಸ್ಕ್ರೀನ್ಶಾಟ್ ಹೊಡೆದ ಈಗ 7:30 ಅನ್ನೋ ಕಳಿಸ್ರಿ. ಈಗ ಮಾಡಕ್ ಕುಂದ್ರಿ. ಹೌದಾ? ಇವೆರಡು ಕ್ವಶನ್ ಮಾಡಿ ನನಗಷ್ಟು ಮಾಡಿದ್ದು ಸ್ಕ್ರೀನ್ಶಾಟ್ ನೀವೆಲ್ಲರೂ ಕಳಿಸ್ಬೇಕು. ಗೊತ್ತಾಯ್ತು? ಕಳಿಸ್ತೀರಿ?
Yes, sir.
Okay, fine then. Thank you very much for joining the class. I'll be waiting for your answers. Have a good day and bye-bye.
Bye, sir.
Bye, sir.
Bye everyone.
Bye, sir.